Prior to performing analysis on the OmniScan, we're going to activate the display cursors, for which there are a data cursor on the scan axis and S-scan to change the angle, a reference cursor on each axis, and a measure cursor on each axis. We will perform length sizing on the scan axis and depth and height sizing on the ultrasound axis, and demonstrate the recording of two of the flaws. The first flaw that we see is plotting directly to the weld center line, high amplitude, ID connected flaw, very typical of inadequate penetration. Other indications in the same area of the weld would be root non-fusion, typically seen differently from one side of the weld than the other, and geometric reflectors based on the weld bevel and type. Here we have an indication plotting directly to the cap on the end of our second leg. We have the first skip B0, the end of the second skip T1, and we have an indication very typical of cap geometry plotting right to T1, typical throughout the C-scan. The next indication, we have a very high amplitude planar type reflector, no jagged edges or peaks, fast rise and fall time on the A-scan, very typical of sidewall lack of fusion. The length of the flaw is recorded on the C-scan either by doing a 3 or 6 dB drop on the color palette, or using the data cursor and the amplitude reading to take a digital number for our 6, 3 dB drop, or whatever the code in the procedure requires. The delta between these two cursors on the scan axis is the length of our flaw. We can measure the depth and the height, or through wall dimension, by either using the color palette to determine our 3 or 6 dB drop, or the angle cursor on the S-scan while watching the amplitude. We identify the top, take the data cursor back to its maximum position, and identify the other edge in between these two focal laws. Place the reference cursor at this point. The delta between the reference cursor and the measure cursor is our through wall dimension. We have sidewall lack of fusion at a depth of 17 millimeters with a through wall dimension of 11.65 millimeters, the center of the non-fusion at minus 79 millimeters on the skew 90 side of the weld center line, and the top at 11 millimeters from the weld center line. We put the cursors back into position to record the flaw. Activate the database, and the entry is added with all the relevant statistics. Moving on to the next flaw, we see cap geometry, and as I move into the next flaw, we see a different type of indication in the S scan and in the A scan. Notice the multiple jagged peaks and edges, long rise and fall time, multiple tip diffracted signals. We know this is connected to the surface because it plots right at T1. We have a very clear, sharp, multiple peaks indicative of an outside diameter crack or toe crack. Notice the difference between the signal in the S scan and the A scan of cap geometry, of a linear indication such as sidewall lack of fusion, and of an indication of a crack. All the tips and facets of the crack are generating small tip diffracted signals. We will identify the start of the crack on the scan axis. We'll walk through the crack, identifying the center of the deepest tip diffracted signal we can find, and as I move my cursor, every time I see a deeper tip, I'll move my cursor to the center of it. We're only interested in the center of this energy. We'll identify the far side of the crack with the green reference cursor, and we'll go back to the worst case spot where we have a very clear tip signal, where we have identified the deepest ligament of the crack at 6.42 millimeters deep from the outside surface at a position of 15 millimeters. This is the volumetric position on the index axis, or the position in and out of the weld for the signal in gate A. And we will record the associated information into the table as well. Menu, File, Report. We can adjust the format, select from several options: custom user fields, probe information, notes if needed, and build the report. The report includes the basic information from the OmniScan and software, all of the phased array setup information, UT information, gates, TCG points, the calculator, our scan area, and the defects we recorded with images if we selected. The report can be signed and printed out directly off of the OmniScan, or it can be saved and closed on the flash card for offline analysis or editing on a computer.